Good morning, everyone. Good morning to you, sir. So, today we will talk about Lesson 4, the derivative of inverse trigonometric function. The reporters for today's lesson are Seringan Tricia May S., Braga Chris Adrian, and Niyar Charming E. First, let's have the pre-discussion. In this section, we are going to look at the derivatives of the inverse trigonometric functions. We will need the formula from the last lesson relating to the derivatives of inverse functions. So, if f of x and g of x are inverse function, then g prime is equals to 1 over f prime times the g of x. Recall that the two functions are inverses if f times g of x is equals to x and g times to f of x is equals to x. So, what to expect? Find the derivative of inverse trigonometric functions using our examples. The following are the formulas that we have to equivalent to all of our equations that we must use into our examples in the next slide. So, these are the formulas that we are going to follow. We have for our sine, cosine, tangent, cotangent, secant, and cosecant. The following are the illustrative examples that we are going to solve in the next slide. So keep on watching and listen for more explanations in solving the problem in terms of derivative of inverse trigonometric functions. First, let's have reporter number 1, Miss Seringan Tricia May S.
Sample letter A. 4 cosine raised to negative 1x minus 10 tan raised to negative 1x. So, the formula that we need is the derivative of arc cosine of u. It's very similar to the arc sine of u formula. It's gonna be negative u prime instead of positive u prime, divided by the square root of 1 minus u squared. So, 4 cosine raised to negative 1x. The u is x and the u prime is 1. So we can plug this into the formula. So therefore, the derivative of inverse 4 cosine raised to negative 1x is 4 over square root of 1 minus x squared. Then next is the 10 tan raised to negative 1x. The derivative of the inverse tangent formula is u prime over 1 plus u squared. So, the first thing needs to find out is what will be the u. So, our u is x and our u prime is 1. So, we know that the derivative of 10 tan raised to negative 1 is 10 over square root of 1 plus x squared. Then, we multiply it to the derivative of x, which is 1. So, 10 over square root of 1 plus x squared times 1 equals to 10 over square root of 1 plus x squared. So, the derivatives of 4 cosine raised to negative 1x minus 10 tan raised to negative 1x is 4 over square root of 1 minus x squared minus 10 over square root of 1 plus x squared.
So, next problem, we have 4 sine raised to the power of negative 1 times the quantity of 1 minus 2x. So here we have 4, so it's a constant number, so it will become 0. And our u in the equation is the 1 minus 2x, and its derivative is negative 2. So from the problem, our inverse trigonometric function is the sine minus 1. So the formula that we are going to use is the arc sine u is equals to sine negative raised to the power of negative 1 u. So it is the derivative of u over derivative of x all over the square root of 1 minus u squared. So this time, let's plug it into the formula. So we have our u, which is the 1 minus 2x. So ito yung nasa taas. Then our denominator has a square root of 1 minus the quantity of 1 minus 2x squared. Then let's define the derivative of our u, which is the negative 2. That would be our numerator. Then in our denominator, we have to evaluate the expression of a 1 minus 2x squared. So using FOIL method, we could have 1 minus 4x plus 4x squared. So now the whole expression will be negative 2 all over square root of 1 minus the quantity of 1 minus 4x plus 4x squared. The next, we have to evaluate the expression of square root of 1 minus the quantity of 1 minus 4x plus 4x squared, and the result will be 2 square root of x times the quantity of 1 minus x. So now we have our numerator, which is negative 2, and since of that, we have now negative 2 all over 2 square root of x times the quantity of 1 minus x. Then we have to distribute x to the quantity of 1 minus x. So we can have now the x minus x squared. Then it would be negative 2 over 2 square root of x minus x squared. So since we have negative 2 in our numerator and 2 in our denominator, we have to divide each to each other. So it would become negative 1. So our final answer would be negative 1 all over the square root of x minus x squared.
I'll discuss the third example, x tangent raised to 1 for x. So in order to solve this one, I will point out that we are going to have to use a product rule. So here we have our first function, x, and the second function, which is tangent raised to negative 1 for x. So using the product rule, then we'll say that it is our first function, x, just as it is, no changes, multiplied by the derivative of the second function. So continue on with our product rule. Now I'll take my second function, tangent raised to negative 1 for x, and change multiplied by the derivative of the first function, x. So next we're going to copy x, then multiply to the derivative of tangent raised to negative 1 for x. So applying the formula of the inverse trigonometric function, which becomes 4 all over 1 plus 16x squared. So moving on, second function, tangent raised to negative 1 for x, times to the derivative of the first function, x, which is 1. So the result is tangent raised to negative 1 for x. So moving on, x times 4 all over 1 plus 16x is 4x all over 1 plus 16x squared, plus tangent raised to negative 1 for x, and that's it for our third example. So for our fourth example, square root of x sine raised to negative 1 for x. So yung nalagay sa module is direct answer na agad. But the same method pa rin, product rule, but it is quite different in terms of replacement kasi square root yung first function. So the first function, as what I have mentioned, is the square root of x, and the second one is sine raised to negative 1x. So using the product rule, so this time we're going to put the derivative of the first function on the first part. So derivative of square root of x times the second function, which is sine raised to negative 1x, plus the second function, sine raised to negative 1x, times to the first function, square root of x, unchanged. So moving on, so square root of x is the same thing as x raised to 1/2. Therefore, by the power rule, the derivative of x raised to 1/2 is 1/2 x raised to negative 1/2 times sine raised to negative 1 x plus, so the derivative of the formula of inverse trigonometric function of sine raised to negative 1x is 1 all over square root of 1 minus x squared times square root of x. So next, copy 1 over 1/2 x, 1/2 x raised to negative 1/2 sine raised to negative 1 x plus, so 1 all over square root of 1 minus x squared times square root of x is square root of x all over square root of 1
Example letter E.
minus x squared.
Y
So
equals
that's it
sine
for
raised to
the
negative
fourth
1 x
example.
cubed. If we take the derivative of inverse sine, the formula will be d over dx sine raised to negative 1u equals dx over du over square root of 1 minus u squared, or sine raised to negative 1x equals to 1 over square root of 1 minus x squared. So to take the derivative of inverse sine, we have x cubed, and the derivative for sine raised to negative 1 is 1 over square root of 1 minus open parenthesis x cubed close parenthesis squared. Because using chain rule, the inside would stay exactly the same. Then next is we multiply by the derivative of x cubed, which we have 3x squared. So 1 times 3x squared equals to 3x squared. Our numerator is 3x squared, and to find the denominator, we just multiply the exponent. 3 times 2 equals 6. So it will be square root of 1 minus x raised to 6. So the derivative of y equals sine raised to negative 1 x cubed is 3x squared over square root of 1 minus x raised to 6.
Our last example is letter F, which is cosine raised to the power of negative 1 square root of 1 minus x. So from the problem, we have to use the formula of cosine, which is negative the derivative of u over derivative of x all over square root of 1 minus u squared. So from the problems, so our inverse trigonometric function here is the cosine raised to the power of negative 1, and our u here is the square root of 1 minus x. So from the given of the problem, since we have our radical, which is the square root of 1 minus x, we have to transform it into exponential form, which will be 1 minus x raised to the power of 1/2. So since now that we have our u, and our the derivative of our inverse trigonometric function is cosine minus 1, so its derivative is square root of 1 minus u, which is our u, is 1 minus x squared. So our derivative of u, which is 1 minus x raised to the power of 1/2, so we have now our negative 1/2 times 1 minus x raised to the power of negative 1/2. And then, ang mangyayari doon sa ating 1 minus, yung sa ilalim natin na naka-square root is, kailangan nating ibalik into radical form yung ating exponential form na 1 minus x raised to the power of 1/2 para ma-execute natin siya or ma-evaluate natin siya. So, yung 1 natin is remain na siya yung 1 minus yung u natin, papalitan na natin ng square root of 1 minus x. So, square root i-cancel natin yung squared natin sa ibabaw, tapos yung square root para maalis siya. So, ang may iwan na lang is 1 minus 1 minus x. So, 1 minus 1 is equals 0. So, ang may iwan na lang is yung square root of x. At ang mangyayari ngayon is ima-minus natin yung negative x doon sa negative ng 1 half. So, ang mangyayari is ibababa natin yung 2 as our denominator and may iwan yung 1. Then, ibababa natin yung 1 minus x since negative yung 1 half natin. So, now we have our 1 over 2 square root of x times the quantity of 1 minus x. Then, didistribute natin yung x towards the quantity of 1 minus x. So, ang mangyayari na is, we have now 1 over 2 square root of x minus x squared. So that's all on how to solve and finding the derivative of inverse trigonometric function. Here are some assessment that you can try in finding the derivative of inverse trigonometric function. So that's all. Thank you and God bless everyone.